Previous video we learned what are the typical values in given data. So coming to measurement of variances will provide the how the variables distributed, the shape of variables distribution. We can know by using measurements of variances. So we have first one is range. Range is basically the max of given data minus min of given data, that will be range. Second one is variance. Variance is the process of distributing of data from the mean. That means how the variables are plotted from the mean basically. So variance of sample we can calculate by using equation, that is 1 by n minus 1 multiplied by each element. We need to subtract mean from each element and we need to whole square. So 1 by n minus 1 multiplied by xi minus x bar of square, that will give variance of our data. So once we know the variance, we can calculate the standard deviation. Standard deviation basically gives the how close the given data to the mean. So standard deviation equals to sample standard deviation equals to root square of s square. S is our variance. So once we know the standard deviation, we can calculate the standard error. Standard error is utilized to identify how close the sample mean to the population mean. Okay, you understood how close the sample mean to the population mean. So to the equation of standard error equals to s by root n, s whereas s is standard deviation. So by using these typical values as well as our measurements of variances, we can identify how our data, what is the shape of our data. For example, in any good data, the proper data always should look like normalized. Our mean, median and mode are positioned at the same point, then we can call it as our data is in normally distributed data. That means our data is in looks like parabola. If you graph it in xy, so our data looks like parabola when mean, median, mode are almost in same position. If median is less than mean is less than median or mode, then we will say it as right skewed. That means mean is at the right position, right? That is positively skewed data. If mean is at left position, then we call it as left skewed position. That means negatively skewed position. So at any point of time in our given data, the data almost 68.4% of data lies in between -1 and +1 standard deviation. 95.2% of data lies between -2 and +2 standard deviation. 99% of data lies in between -3 and +. If any data lies below mean -2 standard deviation or more than mean +2 standard deviation, then we will call it as outlier.